clearly my objective is to convince you, Carlo, that Hyperloop could be part of the future of transportation. and I'll ask the questions to everyone at the end to make sure that you well understood.
Okay, guys. So this is going to be like X Factor. You're going to vote in the end, okay?
No vote.
Yes, definitely. So let's start. So first, the vision we have at TransPod. So my name first, Sebastien Gendron. I'm CEO and co-founder of one of the Hyperloop company, one of the main one, which actually raised initially some money from Italy. And I'm thankful for the country because you're taking the lead and you have the courage to invest into innovation. So the vision is really to connect cities, businesses with an ultra high-speed transportation system. And the mission we have, it's of course to develop it within the next 5 years. And I'll clearly share with you how it's going to work. That we're not talking about science fiction, and that's clearly happening as we speak. And hopefully we'll get some question at the end. So just a bit of a background. So first of all, we're not talking about a concept which is just came out from Elon Musk in 2013. It's a concept which is more than 100 years old. We started to see some initial design at the beginning of the later century, so it's not something new. We actually had some initial design in the late 90s and early 2000. One company called Swiss Metro was really about to implement that system in Switzerland. They had a concession between Lausanne and Zurich, and due to lack of political support at that time, and with the financial crisis in 2008, unfortunately, they went bankrupt. So the key game changer now is that we have one billionaire in 2013 who said, you know what? After train, boats, planes, and cars, that might be good to think about something innovative and new for, I would say, the 21st century. And said, look at that concept, which is pretty basic. It's to put a vehicle into a vacuum tube, to remove aerodynamic friction and to achieve speed at the same, to the same level to an aircraft. Meaning that we already fly and travel today at that speed. Again, it's not science fiction. So after Elon Musk, two competitors started in the US, one of them being Virgin. So not only Elon Musk joined the race now, but also Richard Branson. So Anne was mentioning that we have 8 companies. It's actually even more. Now it's over 10, 11 or 12 companies which are developing that. And we got 2 billionaires. So there's definitely a momentum. And weeks after weeks, we get news related to that. However, the good news for us is that we're not American. And this is great. This is great because we have a boulevard in front of us. And today we're developing TransPod in collaboration between Canada and Europe. And when I mean Europe, it's Italy and France. So a few words on the technology. Again, so we're looking at vehicles traveling in a vacuum tubes. The vehicle is the size of a train coach, so it's 25 meters long. So it's we're designing a bus, okay? It's the size of a bus. We're not designing an aircraft. And we have pods with 80 seconds headways traveling into that vacuum tube, which are using aerospace technology today, and I'll explain a bit more about that, within a steel tube. So the infrastructure is pretty basic, and clearly the value proposition to avoid the extra amount of money you need to have a maglev technology, the value proposition from TransPod is to keep the technology on the vehicle and not on the tube. I'll go more in detail. So clearly, as you are in a vacuum, today we're looking at pressure in the tube around 100 Pascal. So it's kind of being at the equivalent of flying at 50 kilometers above ground. Today, aircraft fly at 10 kilometers. So we're looking at a vehicle with a structure which is similar to an aircraft. It's pretty much an aircraft without wings. We're working already today with Liber Aerospace related to the pressurized cabin. We're looking at space application as well. Just to give you a bit of insight, as we have a pressure delta, which is higher than for an aircraft, we've been looking at seal around the passenger door, We've looked at those used in the aerospace industry. They're not good enough, so we've been looking at the one used for the American space shuttle. The only problem we have is that the seal they've been using, the unit cost was about $15,000, so we just need to produce a bit more to reduce those costs, but this is something which exists today. Regarding a few other items like the thermal management system, this is something we've been looking at what they've been using for the International Space Station. So really reintegrating, and this is the challenge we have, existing technology which are used in the space and aerospace industry to a ground transportation system. And you'll get some more questions too. Key aspect on the engine for the propulsion and levitation system, we're using maglev type technology, and we'll talk about more, but without the drawback of the maglev system used in Japan. The infrastructure, basic steel tubes, 4-meter diameter steel tube. We've looked at the oil and gas industry. They go up to 2 meters, so they don't have the expertise. Those who got the expertise to design those tubes is the windmill industry. So they know they go up to 6 meters. And the real advantage of that infrastructure is that by installing solar panels on that, you may have tomorrow 500, 700 kilometers of line with solar panels, and the energy balance down the road is positive. So even if the system is connected to the grid, with solar panels you get more energy than it consumes. So a better energy, I would say, balance than current high-speed trains. The market. So it's not a point-to-point corridor. Of course, tomorrow the objective is to do, for example, Rome to Milan in 45 minutes. And if you have tomorrow that corridor available, I'm pretty sure that everybody will take it. However, as we're dealing with a small capsule, so today we're sizing the capsule for, I would say, 25 to 50 passengers. You will have the express route. So you have the express route between Milan to Roma. I don't know what, anyway, I'll use another example. I know better that landscape between Toronto and Montreal. You have Ottawa in the middle. You'll have 9 pod out of 10 will go straight to Montreal, and you'll have 1 which is going to stop in Ottawa or Kingston. Meaning that you won't have to stop an entire train, okay, and block all the passengers inside. You will really modelize and make sure that you will have the right amount of pod which is going to stop in Kingston or Ottawa, and the express route to your final destination. So that's one market. The other market, so this is for passengers. The other one for shorter lines, we've been working with some airport authorities around the world to connect city downtown to airport downtown. So it's to apply the same model as the line, the only commercial line which exists today between Shanghai Airport and downtown Shanghai. The only issue with that line today, so it's a 30 kilometers line. It goes up to 400 kilometers an hour. They do that in 10 minutes, but the cost per kilometer is 100 million per kilometer, which is way too expensive, and that line is not commercially viable. On our side, we're 5 times cheaper, so it's really to have the pros from the maglev without the cons to have a better, I would say, market penetration down the road, and all the airports are interested into that. The other aspect too as well is freight. So we're not looking at maritime containers. If we think about, I know that some of our competitors are looking at maritime containers. Maritime containers, they've spent 3 weeks in the sea. What's the point of speeding up the container for the last 100 or 300 kilometers? However, the freight segment where there is lots of interest is e-commerce and food. So lots of feedback positive feedback from DHL, FedEx, UPS, all the postal companies and so on are really interested, and also the food. Today the food, there is 30% waste because of transportation. I know a friend who got a cheese company in Montreal. When the cheese achieved Toronto, 30% garbage. So this is clearly a waste, and they can improve their business case down the road. Regarding freight, so I agree with Carlo on some point. Europe is not our primary market. We're looking at Canada, US, Middle East. Something to know is that high-speed train and sand doesn't work really well. To come back on the aircraft, I'll share a bit the story I had on Sunday. We had a pretty bad weather in Toronto. I had to book 3 flights. They got cancelled in a row because of snowstorm, and they were stuck. I had also another question from someone say, okay, if we have that system tomorrow, don't you think that we'll have security checks and so on? As I'm flying way too much now, I can tell you that airports have been pretty efficient with safety checks. The issue now is when the aircraft has to go to the de-icing station because it can't take off, or when you land, has to wait for a gate to be available to be able to unload the aircraft. Also, another aspect is that airports today, they have to manage an air traffic growth between 5 to 10% every year. What they're looking between Toronto and Montreal is to remove all the domestic flights the same way Europe did between Paris and Brussels, or even between Paris and London, where the Eurostar is doing really great. And it's to be able to replace domestic flights with long-haul flights to generate more revenues for the airport, but also to delay CapEx expenditures when they have to expand the airports, when they can. We've seen recently in France that the big airport on the west side have been cancelled because people don't want it. So we'll have to, I would say, contribute and develop another system which complement all the others. We're not in favor of this is going to be the future, or flying cars, we're going to be that future, or the system developed by Carlo. It's in addition to what we have to address challenges we have, and also contributes to reduce greenhouse gas emissions. Just to finish on freight, because I don't have much time. Freight, today between Toronto and Montreal, it's 10,000 trucks per day on the road. That system, feedback from DHL, will capture 20% of that market. 20% of 10,000, it's 2,000 trucks per day, and the system will run at full capacity only for freight. We'll have to add additional tubes or system to transport passengers. So that was the market side. Passenger experience. That railway station is actually right downtown Toronto. So we want to keep the same value proposition as trains to go from downtown to downtown. And of course, to be able to manage the acceleration, we'll have to decelerate. That system won't arrive at 1,000 kilometers in the stations, but we'll have to decelerate the same way high-speed trains do today. So this is some work we've been doing with an architecture firm to rethink as well the passenger experience, with mixed between what we know with railway stations and airports. As you know today, we start to have, unfortunately, safety checks even for high-speed trains. So that we try to integrate that as much as we can to be efficient. Some boarding procedures too as well. Talking slightly about the design, we're looking at that. It's interesting because I've seen a picture on your presentation regarding a company here in Milan called Quelux. They've been able to recreate the sky, and it's amazing. I've seen their product. It's fantastic. You don't have the impression to look at a screen. And in terms of environmental experience, we're looking at the claustrophobic aspect, of course, because you are enclosed in a tube, but to have a 360 environment, and then to project whatever we want. It could be the scenery between Roma and Milan, or you could be in the Bahamas. We've been even joking about, okay, let's project the latest Star Wars movie. The only issue with the movie is that you'll have to do multiple trips to see the entire film. Anyway.
It's a good.
Yeah. An example, that's the one we've been talking about, intermodality, looking at the last mile delivery too as well. We don't pretend to have the tube going straight in front of the door. We'll have to work with companies like such as Uber, such as what you're doing, to interconnect everything and make sure that the customer experience or the customer got everything on his app to do from his doorstep to where he wants to go on the other side using autonomous cars and so on. Engineering development, got 30 seconds. The good news is that we got the support from both the Canadian and the European Union to develop the regulation with us. The Minister of Transportation, Marc Garneau, is a former astronaut that's probably playing a role in that, agreed to join a working committee to develop the regulatory framework with us. And we got the feedback also from the European Transportation Commissioner, Violeta Mrs. Bulk, which is on board, and it's part of their mandate to develop that. The same way we had the steam train, diesel train, electrical train, high-speed train, it's the next generation vacuum train, and we don't plan to reinvent the wheel in a way that, as you are dealing with many aerospace technologies, we'll reuse some safety requirements from this industry to avoid having to rewrite everything. The plan, R&D development is starting in Italy. We got some grants thanks to our investors, industrial investors. There is a test track. We plan to start the construction in fall in Limoges, so it's 3 hours south of Paris. Well engaged, and we are in good shape to close the next round of funding with major player, I would say, from the infrastructure industry and also financial institutions. Roadmap, and then I'm done. 5-year plan, certification by 2025, and at the same time to start the construction. And at best, if we follow the schedule, we might have a line before 2030.